In the modern banking world, billions of transactions move quietly across digital highways every day. Within those numbers lie patterns of trust and, sometimes, deception. At one of India's largest banks, a senior data scientist named Priya begins her morning facing this ocean of information. For years, analysts like her depended on traditional scripting, SQL extraction, and machine learning models built line by line. They were powerful, but rigid. Every new dataset demanded hours of manual configuration before insight could even begin. Then came a shift. Large language models capable of understanding natural language and generating analytical logic from it. Priya was one of the first in her division to realize what that meant. If she could learn to guide an AI model through precisely phrased prompts, it could work alongside her, exploring, cleaning, visualizing, and summarizing far faster than any manual process. She called it turning thought into analysis. This story follows how she rebuilt her entire fraud analytics workflow using prompt engineering. It's not science fiction. It's what many banks are beginning to test today, a partnership between human judgment and machine reasoning. As the morning dashboard loads, Priya prepares to face the same challenge every fraud analyst knows too well: too much data and not enough time. Yes. Every morning, as the city wakes, Priya's system lights up with new data, hundreds of thousands of transactions streamed overnight from across India. Each entry looks harmless: amounts, timestamps, merchant IDs, device fingerprints. Yet, buried among them, a few will hide traces of fraud: accounts taken over, cloned cards, networks of mule transactions. The sheer volume is staggering. Even with automation, traditional analytics pipelines move slowly. A typical fraud model might take hours to process data, and its results still require human review. By the time reports are ready, more fraudulent transactions have already slipped through. This is the central challenge in fraud analytics: speed versus accuracy. The faster we act, the less we lose. But the faster we move, the less we explain. Executives want answers. Regulators want transparency. Analysts want both. Priya used to spend most of her day in preparation mode, querying data, merging tables, debugging joins. Only by late evening would she reach the stage of interpretation, the part she loved most. The process was efficient for code, not for curiosity. Prompt engineering offered something new. It didn't replace her statistical tools. It changed how she interacted with them. Now she could ask a model in plain language, "From this dataset, tell me which patterns differ most from last month's normal behavior." And the AI would respond with logic she could verify. The challenge of fraud analytics remained, but for the first time, Priya had a way to think faster than the fraud itself. With that shift in mindset, we step into her world to see how she works, not through dashboards and code alone, but through conversation with an intelligent system. Priya sits at her desk, a quiet corner on the 14th floor of her bank's data science division. Around her, large monitors display live dashboards, fraud alerts, regional transaction maps, and risk heat scores that constantly flicker between green and red. To most, it looks like chaos. To Priya, it's a living system, one she has learned to listen to. Her role is not only technical, she bridges two worlds: algorithms and accountability. On one hand, she speaks Python and SQL fluently, designing predictive models that score every transaction for risk. On the other, she explains those results to compliance officers and business heads who need stories, not scatterplots. A single misunderstanding can freeze legitimate payments or overlook criminal ones. That tension defines her day. She often jokes that she works not just with data, but with doubt. Every decision must be defensible. A reason behind every flag, a logic behind every alert. But the tools she used until now limited how quickly she could reason. Traditional fraud detection models output probabilities, not explanations. When something looked wrong, Priya had to trace it back through features and logs to reconstruct the why. It could take hours. That changed when she began to apply prompt engineering. Instead of treating the AI model as a black box, she started treating it as a collaborator. She could ask, "Explain why these transactions have a high anomaly score," in business terms. and it would reply with human-readable reasoning. The relationship between analyst and AI had evolved from coding to conversation. As the morning begins, Priya opens her first dataset of the day, the same work she's done for years, but with a completely new companion by her side. Before she began using prompt engineering, Priya's workflow was as methodical as it was exhausting. Every investigation started with data. Too much data. First came data extraction. She'd write long SQL queries to pull transactions from multiple databases, payment systems, card authorizations, mobile apps, and ATMs. The result? Gigabytes of CSV files, each one slightly different in structure, column names, and time zones. Then came data cleaning. She'd check for null values, remove duplicates, standardize timestamps, and merge sources. One mismatched date format could throw off an entire model. She often spent more time fixing formatting errors than analyzing behavior. Next, feature engineering, creating new metrics the models could use, the number of transactions per customer per day, the average distance between purchase locations, the time gap between consecutive high-value payments, all of it coded manually, step by step. By late afternoon, she'd move to model training, running anomaly detection or supervised classifiers. Each run took time, and every change meant another rerun. Finally, there was reporting, summarizing findings into PowerPoint decks for risk managers, simplified charts, annotated tables, and written summaries. It was accurate work, but painfully slow. And that slowness had a cost. Fraud rings move fast. A card compromised in the morning could fund 10 mule accounts by evening. Priya's team was skilled, but human speed was no longer enough. She often thought, if I could just talk to this system directly, explain what I'm seeing, and ask what it thinks, maybe we could keep up. That thought stayed in the back of her mind until she discovered a way to make it real. Tomorrow's workflow would look nothing like this one. The first morning Priya tried prompt engineering, she didn't change her data. She changed her approach. The same mountain of transactions loaded on her screen, tens of thousands of rows, each one another thread in a web of digital activity. But instead of opening her SQL editor, she opened her AI interface, a simple chat window connected to her secure analysis environment. She began cautiously. Greater than summarize key statistics from this dataset and identify columns most relevant to fraud detection. In seconds, the model responded with a list of potential features. Not code, but reasoning. Columns such as transaction amount, timestamp, merchant category, and device ID have shown strong correlation with historical fraud events. Missing values detected in merchant category suggest feature scaling for amount. Priya leaned back, surprised. It wasn't perfect, but it understood context. She followed up. Generate Python code to clean missing values, encode merchant categories, and normalize the amount field. Clean, commented code appeared. Code she would normally write herself, but faster and consistent. She copied it into her notebook, executed, and reviewed. No errors. Then she asked, add a feature representing distance between consecutive transactions for each customer. Again, instant logic. The model calculated distances using latitude and longitude columns, creating a new feature travel distance kilometers. By lunch, Priya had built an entire feature set, not by manual coding, but by conversation. She still validated every step, but the hours once lost to scripting were now spent on thinking. For the first time, she felt her workflow align with her curiosity. Instead of commanding a machine, she was collaborating with one. The tools were the same, but her dialogue with data had changed forever. The dataset Priya worked on wasn't theoretical. It was the real daily transaction feed used by the bank's fraud detection unit. Hundreds of thousands of entries collected over 24 hours, refreshed every morning at 6 a.m. Each record told a fragment of a customer's story. A timestamp, a transaction ID, the merchant category, the device used, the latitude and longitude, and finally the transaction amount. To a machine, these were just numbers. To Priya, they were habits, patterns that could reveal who a person was, and more importantly, when that pattern didn't make sense anymore. In the past, exploring this data meant hours of filtering and cross-checking. Now, She started with a single prompt. Summarize this dataset. Count records, show key columns, highlight outliers or missing values, and report any irregular data patterns. The AI responded almost immediately. Dataset contains 97,214 records, columns with high variance, amount, time of day, and location. Missing merchant categories, 2.1%. Unusual transaction bursts detected between 12 p.m. and 4 a.m. Average amount 92,000 rupees. Priya's attention locked on that last line. Between midnight and 4 a.m., transactions had spiked, something that rarely happened in this customer segment. She probed deeper. Show transactions above 90,000 rupees between 12 p.m. and 4 a.m. Include customer ID, city, and device ID. The system filtered and produced a small table. 3 customers, 5 transactions, across 2 distant cities. Same time window, similar amounts, and 1 device ID repeated twice. That device ID, DX2219, stood out like a fingerprint. Priya cross-referenced it against last week's data with another prompt. Greater than, check if device DX2219 appears in previous datasets. The AI replied, device DX2219 used by 3 different customers in the last 7 days. That was her first lead of the day, a pattern that no simple SQL query would have surfaced so quickly. Prompt engineering wasn't just accelerating her work, it was changing her way of seeing. Each request became an intelligent lens, scanning the data from a new angle. And as she uncovered her first anomaly, she began to wonder how many other stories were hidden here, waiting to be told. Finding anomalies was easy. Explaining them, that was the art. In banking, speed without clarity is risk. Every flagged case demands justification. Why this, not that? Priya crafted a prompt with intention. Detect suspicious clusters in transaction data and explain, in business terms, why they appear unusual. Within seconds, the AI produced insights like a well-trained analyst. High-value night transfers across cities, possible credential compromise, repeated microtransactions below limit, potential mule account behavior. But one cluster seemed off. It grouped unrelated low-value transactions. She questioned it. Explain reasoning for cluster 4. The model admitted, pattern similarity based solely on timestamp proximity. She realized she had overgeneralized the prompt, so she refined it. Exclude timestamp similarity as a criterion unless paired with same device or merchant ID site. The new output made sense. This was the lesson. Prompting isn't just asking, it's teaching precision. For Priya, this changed everything. Now she could explain results in plain English, traceable, transparent, and defensible. She wasn't fighting with data anymore. She was reasoning with it. To test improvement, she ran a controlled comparison. Her baseline prompt was simple. Detect anomalies in this dataset. The AI obeyed, listing a handful of outliers. Technically correct, practically useless. No context, no story. This is where many analysts stop, and where Priya began. She reprompted. Use anomaly detection on amount and timestamp columns. Better, but still shallow. The AI didn't know what anomaly meant in banking, so she asked herself, what's missing? Intent, role, scope. She wrote again, you are a fraud data scientist. Detect anomalies that indicate possible account compromise or mule behavior. Immediately, the tone changed. The model filtered noise, connected behavior, and began reasoning. For the first time, the AI was thinking like her. Now she refined with structure. You are a senior fraud analyst at a retail bank. Analyze this transaction dataset using amount, timestamp, location, and device ID. Identify behavioral deviations from customer norms. Estimate fraud risk and explain reasoning in plain English. This prompt produced results that read like case files. Customer 2451, Delhi to Bengaluru within 4 hours, new device. Behavioral deviation, time, geography, device change. Risk, 82%. It wasn't just data, it was dialogue. By defining role and audience, Priya transformed the AI from a general model into a contextual expert. She saved the template, fraud analyst prompt, context aware, and added a note for her trainees. AI mirrors clarity. Speak clearly, and it reasons clearly. That line became a mantra in her department. With the refined prompt running on full data, results poured in, structured, reasoned, and readable. Clusters labeled with confidence scores and plain language explanations. Each line a mini narrative. High value midnight transfers. Risk 87% due to new device DX2219. The callback from earlier, proof of traceability. The AI even wrote recommendations. Implement device re-verification after high-value night transactions. Trigger customer alerts for repeated device re-registrations. What once took 8 hours now took 20 minutes. But speed wasn't the real achievement. Explainability was. Executives could finally read insights and understand them. Every flag had a why, every pattern a because. As Priya saved the report, she realized she had achieved what every analyst dreams of, results that were both fast and defensible. And with those insights ready, she turned to the next step, turning numbers into pictures, because the quickest way to make data actionable is to make it visible. Numbers convince analysts, visuals convince leaders. Priya understood that the true power of insight lies in how fast it can be seen. She prompted, generate Python code to visualize anomalies by transaction amount and time of day. Highlight risks above 80% in red. The AI returned precise code. She ran it and a scatter plot appeared. A galaxy of dots, most calm and gray, a few glowing red at the edges of normalcy. Each red flare marked danger, late night, high-value activity. Among them, that familiar device ID DX2219, bright and unmistakable. Annotate the top 5 anomalies with customer and device IDs. The graph updated. Now the story was visible, risk no longer buried in tables, but painted on the screen. Next came a new request. Show anomaly frequency by merchant category. The AI generated a bar chart where spikes rose over luxury retail and online electronics. Patterns became conversations. Visuals replaced explanations. She added both charts to her slide deck. For the first time, she knew her report wouldn't need her narration. The visuals spoke for themselves. Imagine your own dashboards transforming this way, your daily charts becoming stories instead of spreadsheets. Priya's next thought followed naturally. If prompts could visualize, could they also write? Friday evenings used to mean overtime, compressing a week of analytics into a 2-page summary. Now, Priya simply instructed, summarize findings by region and customer risk level in a concise executive tone. In moments, the model produced a professional brief. Northern and Western regions. High-risk clusters between 12 a.m., 4 a.m. indicators. New device registrations, cross-city transactions. Actions. Enhance two-factor authentication. Audit device fingerprints. The style was crisp, board-ready. Then she tried a second variation. Rewrite this summary as an email for the chief risk officer. The tone shifted smoothly, formal but human. We observed a surge in midnight transfers between 2 cities using newly registered devices. Recommend verification updates and alert review perfect. She barely touched a word. What once consumed hours now took minutes, and it read as if she'd crafted it herself. Prompt engineering, she realized, didn't just accelerate analytics, it accelerated communication. Insights could now move through the organization at the speed of curiosity, and the ripple effects were measurable. When Priya presented her first full prompt-engineered report, the reaction was instant. Executives didn't just nod, they understood. For the first time, every flag had a reason. Her manager compared numbers, reports produced per week, from 5 to 25. Average preparation time, down 80%. False positives, reduced 30%. Time to investigate, cut from 12 hours to 90 minutes. Compliance teams celebrated. Clear reasoning chains meant smoother audits. The chief risk officer said simply, "You didn't just speed things up, Priya. You made insight trustworthy." Even more striking was the cultural change. Analysts began asking, "What's your prompt?" the way they once asked, "What's your model?" A new language was forming. Priya felt proud, but she also saw the need for structure. Good prompts were valuable, but great systems were repeatable. She needed a way to document how prompts connected, from exploration to explanation. That's when she designed the prompt stack architecture. Priya's prompt stack worked like a pipeline of thought. At the base lay the data understanding layer. Summarize columns, missing values, outliers. Above it, the exploration layer. Group anomalies by location and time. Suggest potential clusters. Then the reasoning layer, the heart of her process. Act as a fraud investigator. Interpret clusters in business context. Next, the visualization layer, turning text into sight. Generate code to plot anomaly distribution. And finally, the communication layer, executive summaries, compliance briefs, investigator notes. Each layer built on the last. Outputs became context for the next step, forming a reasoning loop. When colleagues saw her diagram, they realized this wasn't just workflow, it was a thinking framework. It could be reused for any analytic domain. Prompt engineering, structured like this, was no longer improvisation, it was governed creativity. But as adoption spread, new issues surfaced. When an AI can reason, it can also err. And that's where Priya's next skill emerged, debugging language itself. Priya discovered that debugging prompts mirrored debugging code, only faster. Her first lesson, vagueness is the enemy. Detect anomalies, produced guesses. Using columns amount, device ID, and timestamp, detect patterns inconsistent with normal customer behavior, produced insight. Second, missing context. Without domain framing, the AI could misinterpret. So, she prefaced every session. This dataset contains retail banking transactions from the past 30 days. Third, unstructured output. Return results in a table with transaction_ID, risk_reason, and confidence. Fourth, guardrails. Use only provided data. Do not infer external information. And finally, interrogate logic. Explain how you reached this conclusion. This last habit taught the AI and her team to reason transparently. When prompts misbehaved, she didn't rewrite the model, she rewrote the conversation. If the AI gives a vague answer, it's because you asked a vague question. That single sentence became a wall poster across her floor. The debugging discipline didn't slow her down, it sharpened her thinking. And soon, that clarity became a superpower. With practice, Priya's workflow felt almost frictionless. What once required complex orchestration now began with a single, well-crafted question. Morning dashboards turned into dialogues. Instead of coding loops, she looped through reasoning. Her focus shifted from syntax to strategy. Peers noticed. Her presentations felt alive, each insight backed by a clear chain of thought. Executives could follow her reasoning step by step. Prompt engineering had made her not just faster, but clearer. She mentored junior analysts, showing how good prompts mirrored good science. Hypothesis, test, refine. Within weeks, productivity doubled. Curiosity returned. "It's like driving an automatic instead of a manual," she'd say. "I still steer, I just don't grind gears." Prompt engineering didn't replace her expertise, it amplified it. It reminded her why she joined data science in the first place, to explore patterns, not fight pipelines. Her next step was to formalize that power into reusable strategies, advanced prompt patterns. Priya's library of advanced patterns grew daily. Chain of thought prompts. List reasoning steps before the conclusion. Identify supporting evidence. This added transparency, essential for audit. Role and constraint stacks. First act as data analyst, then as fraud investigator. Present both views. Now one prompt replaced two departments. Self-verification loops. State your conclusion, then critique your own reasoning and adjust confidence. The AI began catching its own inconsistencies. Structured output formats. Return JSON with anomaly description, evidence, impact. Multi-step inquiry chains. Step 1, identify high-risk locations. Step 2, cross-reference with complaints. Step 3. Summarize root causes. Together, these patterns turned single prompts into analytical frameworks. DX2219, the once mysterious device, now appeared automatically in model checks, proving how scalable these methods had become. As she shared the patterns across teams, the ripple spread: credit risk, AML compliance, customer support, all experimenting. Innovation was accelerating, but so was responsibility. To sustain progress, Priya had to balance speed with ethics, power with control. Scaling prompt engineering across a bank meant navigating governance, data privacy, all prompts executed in a secure, isolated environment, identifiers masked, datasets anonymized, innovation without exposure, traceability, every prompt, every output, every edit logged. The system built its own audit trail. Bias checks. Priya ran counterfactual prompts. If location changes, does risk still hold? This revealed biases early. Human in the loop. No alert closed without human validation. AI accelerated decisions, never replaced judgment. Prompt versioning. Just like code, every revision stored and documented. When auditors reviewed the process, they could replay any analysis step. They even traced the original DX2219 case back to the very first prompt chain, proof that transparency could coexist with automation. The outcome: speed with compliance, intelligence with integrity. Now, with governance in place, it was time to measure the impact not just in anecdotes but in hard data. Priya defined 5 KPIs to prove success. 1. Time to insight, from 12 hours to 90 minutes. 2. False positives, down 40%. 3. Analyst productivity, up 6 times, from 14 to 80 cases weekly. 4. Compliance review, time cut in half. 5. Stakeholder confidence, 92% satisfaction. Behind each metric was a story. The same midnight pattern once found by chance was now caught daily, automatically, thanks to reusable prompt stacks. The notorious DX2219 became a benchmark test. If the system found it, the process was healthy. At the annual review, the chief data officer said, "We're not just detecting fraud faster. We're redefining how intelligence scales." For Priya, those numbers weren't the finish line. They were validation that clarity, curiosity, and precision could transform entire workflows. She looked out across her team, once overworked, now empowered, and thought, if this can change banking, what else could it change? That thought became her closing message to every analyst who would follow. As night fell over Mumbai, Priya closed her laptop. Outside, the city glowed, lights tracing the heartbeat of commerce. Inside, her AI quietly archived the day's prompts, ready for tomorrow's data. For the first time, Priya didn't feel behind. She felt aligned, with the data, with her purpose, with the future. Prompt engineering had taught her a truth she wished she'd learned sooner. Data science isn't about models, it's about questions. The better the question, the clearer the world becomes. And that truth isn't hers alone. It belongs to every analyst, every data scientist, every curious mind watching this. Take one process from your work, a repetitive query, a boring report, and turn it into a prompt. Test it, refine it, teach your AI how to think with you. That's where mastery begins, not with complexity, but with clarity. As she left the office, the final report for the week queued and sent automatically, Priya smiled. What once took her an entire day now took a conversation. And for you, the next dataset you open, the next question you ask, that's your first step. Because the future of data science doesn't belong to those who code the most. It belongs to those who ask the best questions.